So elements and compounds are both examples of pure substances. So elements are the pure substances that are made up of identical types of atoms. It turns out that there are 118 known kinds of atoms. If you'd like to see a sample of an element, and probably the easiest thing for you to grab would be a piece of aluminum foil, and that's really, really high purity aluminum, and there's just the one type of atom present. A compound is a pure substance that is composed of two or more different kinds of atoms chemically bound together. And the important thing to recognize is that the elements or types of atoms that are present in a compound are always there in the same ratio for a given compound. So for example, the compound ammonia always will have 3 hydrogen atoms for every nitrogen atom. If it doesn't have that ratio, then it's not ammonia. The elements that are in compounds are not simply mixed together, they are chemically bound to one another. That means that the elements in compounds can only be separated by chemical means. So, matter can be divided into two broad categories. There are mixtures, which we talked about previously, and there are pure substances, which can be further divided into compounds and elements. If your sample of matter cannot be separated physically, then it must be a pure substance. If you've decided that your sample of matter is a pure substance, you might try to decompose it chemically. If you can break it apart into more than one type of atom chemically, then it's a compound. If it's not possible to chemically break it apart into more than one kind of atom, then it's an element. Okay, so elements are composed of one type of atom, compounds are composed of several types of atoms bound together via a chemical bond, and those atoms will be present in a characteristic ratio for that compound. So, how do we know, how did we find all of these elements, and what's their abundance across the universe? So, what I can tell you is that 88 of the elements are known to exist naturally, and 30 of them have been made in the laboratory. All of the synthetic elements that we made in the laboratory are radioactive and only exist for fairly short periods of time. The universe is quite a boring place. Most of the universe is helium and hydrogen. In fact, about 99.9% of the universe is composed of helium and hydrogen, with 91% of that being hydrogen and about 9% of that being helium. How we know that the universe is composed of mostly hydrogen with small amounts of helium is by looking at what comes at the Earth from space, which is predominantly light. So elements glow when they are energized with a characteristic color. So by examining the light that comes to us from stars and galaxies, we can conclude that the universe is approximately 91% hydrogen and 9% helium. The Earth's crust, the solid part of the Earth, and the atmosphere of the Earth, and also the waters, that is lakes, rivers, and oceans, are mostly oxygen and silicon, so a very, very different composition from the universe at large. So the two most common elements in the on the Earth are oxygen coming in at 60%, and then silicon coming in at around about 20%. And then the remaining 20% of the matter on the Earth is amongst these trace elements. So there are 80 naturally occurring elements and 30 man-made elements. All of the man-made elements are radioactive. Elements are not uniformly distributed. Most of the universe is hydrogen, with about 91% of the universe being hydrogen, and then there's about 9% of the universe being helium. On the Earth, most of the Earth is silicon, running at about 60%, and then oxygen running at about 20%. So every atom type every element has both a name and a chemical symbol. So there are 118 known kinds of atoms, and every atom has its own symbol. The first character in an atom symbol is always an uppercase letter. If it does have a second character in its symbol, then that character will be a lowercase letter. Frequently, the name and the symbol of an element will be quite different because they weren't derived from English. So good examples of this would be K is the symbol for potassium, W is the symbol for tungsten, and Na is the symbol for sodium. You will always be provided with a list of atomic symbols and names, and there's a list like this on the inside cover of your textbook. So it's important to recognize that the elements have both names and symbols. The symbol of an element always begins with an uppercase character, and if it does have a second character, that character will be lowercase. Sometimes the names and the symbols are quite different. You always want to consult with a table rather than guessing.